Alright, this is page 197, number 31, where we have to solve this polynomial equation for t. And first thing I'll do is get it in a standard form with the highest power of t here, and I'm going to subtract the 10t to the fourth from both sides. Get that in the left, so that's the next highest power of t, and then I have my 9t squared. So, even though this is the sixth power here, I have to look at this and say, you always want to take out a greatest common factor. But first, given that t to the sixth is the highest power of x, I'm also going to, right here, acknowledge that there will be 6 roots when I'm done, if I can find 6 solutions to this equation after I factor it. So let's get that greatest common factor of t squared out. And then I'll have t to the fourth minus 10t squared plus 9 equals 0. Now this is looking more like something that you can factor. If this was just a t squared and this was just a t to the first, that would be pretty easy to break that down. You'd have a t and a t, and then for your 9, you'd have a 9 and a 1 with a sum of 10. So it could be a negative 9t and a positive t, except that we need those to be t squareds. Because now I'd have a t to the fourth in my first position. Multiplying these together would be a 9t squared, and this would be a 1t squared. And if those are both negative, then I get my sum of a negative 10t squared in the middle and a positive 9 here. And don't forget that you still have that greatest common factor of the t squared outside. Okay, so now you should recognize these as differences of two squares. We also have the 2 powers of t out here, so I'm going to go t times t is my t squared, and then t squared minus 1 factors to t plus 1 times t minus 1, and t squared minus 9 factors to t plus 3 times t minus 3, all equal to 0. So there you have 6 linear factors of t, 1, 2, 3, 4, 5, 6, and your solutions will be the values of t that make each of those factors 0. So this is a 0, this is a 0, this will be a negative 1, a solution of a positive 1, a negative 3, and a positive 3. So listing those all, from the left, the lowest turn, this is going to be a negative 3, and then a negative 1, and then 0 is a double root, and then a positive, so I got those, positive 1, and lastly a positive 3. So there are your 6 roots, and any of these, when plugged into the original equation, will make it true. And that's it.